Trigonometry, double angle formulae and solving equations. To solve this equation, we can clearly see that we have angle x and angle 2x in the equation, so an angle and double its angle. So we need to use the double angle trig formulae to solve this. We're aiming to have the same angle throughout the equation, which will make solving it easier. So which identity links cos 2x to sin x? So cos 2x is equal to 1 minus 2 sine squared x. So we're going to substitute all of this into here. So now we have 1 minus 2 sine squared x for that term, plus 3 sine x is equal to 2. And if I take all of these terms to the right hand side, keeping the squared term here positive, so then I have 2 sine squared x minus 3 sine x plus 1 equals 0. This is a disguised quadratic which can be factorized as this. So from here we've got 2 sine x minus 1 equals 0, so sine x is equal to a half. And from this one here we've got sine x minus 1 equals 0, so sine x is equal to 1. So the angles that we get from this side, which are within this range, are 30 and 150 degrees, and from this side we get a single angle 90. Another example, this one uses the double angle identity for sine. So sine x is equal to sine 2x. I'm not going to solve this, I'm just going to show the initial steps in the solution. So sine 2x is 2 sine x cos x, and the wrong thing to do now would be to do this, to divide both sides by sine x and then just solve for cos x. You will lose solutions if you do that. Okay, taking the sine x term to the right hand side, so 0 is equal to 2 sine x cos x minus sine x, and then factorizing, so sine x brackets 2 cos x, and from this one here minus 1. So now we have either this is 0, sine x equals 0, or this is 0. So cos x is equal to a half. And then you can solve these within a given range. Another problem here similar to the previous one. So sine a half x is equal to sine x. This one is not as obvious as this here, because you had the angle and double, and it's exactly what you see in the formula and so on. So the angle here is double the angle here. This is the double one, so I'm going to use the double angle formula for sine on this term here. So sine, this is the basic identity. Sine 2x equals 2 sine x cos x. Yeah, this is what you should memorize. Clearly that x there, that angle there, isn't the same as here. So let's rewrite this for this angle here. Well, this standard identity that you've memorized, the angle on the left hand side here is double the angle on the right. So these ones on the right, if you times 2, you get this one, and going back the other way, you're multiplying by a half, you're halving this. So half of 2x is x. So if I'm going from the left here to the right, it will be 2 sine half of this, half x cos a half x. So I'm going to use this to replace that term. So now I have sine a half x is equal to 2 sine half x cos a half x. And then if I move the sine half x term to the right, so we have this minus the sine half x, and then factorizing sine a half x. That's in both of these, so I'm taking the sine half x out. That leaves 2 cos half x minus 1. So from this part we have sine half x is equal to 0. You need to solve this, and 2 cos half x minus 1 is 0, so cos half x is equal to half. You need to solve this within whatever range of values of x are given to you.